All right, let's try to find antiderivatives for some example questions. Number one, integral cosine x over sine x plus 2 dx. Let's use u substitution. Substitute u for sine x plus 2. And then you find the derivative on both sides. In left side, differentiate in terms of x. Right side, differentiate in terms of u. So left side is cosine x dx. Right side is 1 times du. And then you isolate dx from this equation. So dx is equal to du over cosine x. And then you rewrite this given expression in terms of u. So integral cosine x, you already substitute u for sine x plus 2, which is in denominator. So put u in denominator. And dx is replaced with du over cosine x. And now you can cancel cosine x out because one is in numerator, the other one is in denominator. So it's simply 1 over u du. You find the antiderivative of 1 over u in terms of u, which is ln absolute value of u. Don't forget to put c. And then finally, you go back to the original expression for u. U was equal to sine x plus 2. So the answer should be ln sine x plus 2 plus c. That's answer. Number 2. Integral 3 over square root of 25 minus x squared. Wow, this question is a little bit complicated. But I'm gonna find the answer. I'm gonna solve this question based on this. Integral 1 over square root of 1 minus x squared dx. This fraction, 1 over square root of 1 minus x squared, is derivative of sine inverse. So antiderivative of that expression is sine inverse x, right? I will use this rule. First of all, you're going to take out 3. Integral 1 over square root of 25 minus x squared. But I'm going to take out 25 from these two expressions, like factoring. 1 minus x squared over 25. So far, these two functions are same. And then I will take out 5 from that. 5 from root. So it's like 3 integral 1 over 5 square root of 1 minus x squared over 25 dx. And then take out 1 over 5. So 3 over 5. Fraction 3 over 5 is outside. 1 over square root of 1 minus, I will do parenthesis x over 5 square dx. Because if there is linear to the n power form, you can use u sub. Now we can use u substitution for x over 5. X over 5 is u, and differentiate both sides. 1 over 5 dx is equal to du. Isolate dx. Dx is equal to du times 5. So rewrite this equation in terms of u. 3 over 5 integral 1 over square root of 1 minus u squared, because x over 5 is replaced by u, and dx is du. Dx is equal to du times 5. Now you can cancel 5 out. So antiderivative of 3 times integral 1 over square root of 1 minus u squared du is 3 times sine inverse u plus c. Finally, you change u to the original expression. U means x over 5. So x over 5. 3 sine inverse x over 5 plus c. That's answer. Next question, number 3. Integral cosine x sine squared x dx. Do I have to use U substitution? I think you can change the given fraction to cosine x. In denominator, there are 2 sine x because this is sine squared. So it's like sine x times sine x dx. So you change cosine over sine to cotangent x, and 1 over sine to cosecant x. Do you have any idea? You guys already memorized this, right? Cotangent x, cosecant x, that's antiderivative. Derivative of negative cosecant x. Or derivative of cosecant x is negative cosecant cotangent. So the answer is negative cosecant x plus c. Let me erase this part. All right. Next question. Integral secant u times parenthesis secant u plus tangent u. Yeah. Let me distribute secant u for these two. So secant u times secant u, which is secant square u, plus secant u times tangent u du. Yeah, now you can directly find the antiderivative. Antiderivative of secant u is tangent u plus secant u times tangent u. Antiderivative of secant u tangent u is secant u plus c, because derivative of tangent u is secant u, and derivative of tangent u is secant squared u, and derivative of secant u is secant u times tangent u. Next, number 5. That one is linear expression, linear function, 5x plus 1. Whenever there is linear function to the n power form, we can use u sub for linear expression. So substitute u for 5x plus 1, and then differentiate both sides. 5 dx equals du, isolate dx. So dx is du over 5, and then rewrite this equation. Integral 5x plus 1 is equal to u, so u to the 1/3 power, times dx is du over 5. So take out 1 over 5, u to the 1/3 power du, and then find antiderivative of u to the 1/3 power by using power rule of integration. So keep 1 over 5, 1 over 1/3 plus 1 times u to the 1/3 power plus 1/3 plus 1 power plus c. In denominator, 1 over 3 plus 1 is 4 over 3. 1 over 4 over 3 is 3 over 4. So 3 over 4 times 5. And then u to the 1/3 plus 1, which is 4 over 3 power. So the answer is 3 over 20 u to the 4 over 3 power plus c. And then you go back to the original expression, which is 5x plus 1. So the answer is 3 over 20 times 5x plus 1 to the 4 over 3 power plus c.